The Sleipner field is a group of small pockets with natural gas, situated 2,500 meters below the sea bottom. In the very middle of the North Sea, between Scotland and southern Norway. When we started the project, it was known that some of the gas had high CO2 content. So we had to remove the CO2 to be able to sell the gas. Then came up the question what to do about this roughly 1 million ton of CO2 that would come out of that separation process. In the past, when we had too high CO2 content mixed with natural gas. The obvious thing was to remove the CO2, sell the gas and vent the CO2 in the atmosphere. But humankind emits a lot of CO2, and we know that CO2 emissions disturb the climate. So it's the company policy that we should do the best we can within economic finite limits to avoid emitting more CO2 than absolutely necessary. So we wanted to develop technology to store CO2 deep underground, which had not been tried before for CO2. We're now on the Sleipner T for treatment platform. And the natural gas with CO2 comes up through a pipe. We take the CO2 out of the natural gas. The natural gas is sent to the market in Central Europe. The CO2 goes down through one of those pipes you can see over there into a well and ends up 1,000 meters below the sea bottom. When we inject the CO2, we inject it at the bottom of the sand layer. And at that pressure it's liquid, very much like water. But this condensed CO2 is slightly lighter than water, so it will slowly migrate in between the sand grains and collect in the top. But immediately some of this CO2 start to dissolve in the water, like CO2 dissolved in soda water. And CO2 saturated salt water is heavier than the salt water. And then of course it starts to sink down, and eventually all the CO2 will be dissolved and collected in the bottom. We are able to measure the volume, the content and the pressure, and we have now been injecting for 16 years soon, and we have reached close to 15 million tons. Reducing the CO2 emissions of Norway by 3%. Sleipner stands out as the first place where CO2 was injected out of concern for the climate. We have the technology, we have the experience on how to do it. So now we need to find other places around the globe where CO2 storage could be done.
We have learned some lessons from Sleipner, but we need to apply them on a larger scale worldwide. So we have to test the process in the lab using sandstones from each underground storage location. We collect core samples from candidates for CO2 injection in order to see what is happening if we inject artificial CO2. We saturate the pore system with seawater because in the underground, the sandstone formations are completely filled with the seawater. We put the sample in a batch reactor and expose the whole system to the pressure and temperature conditions of a CO2 underground storage location. And after experimental reaction times of weeks up to months, we take the samples out of the batch reactor to see what happens to the samples before and after CO2 treatment. So we observe three mechanisms when we inject large amounts of CO2 in the deep underground. The first mechanism is the trapping in the pore space. It's a physical process, and it's very fast. The next step would be the dissolution of CO2 in the seawater. That is a very slow process. If I dissolve the CO2 in the seawater, I would observe a pressure release. So this would increase safety considerations. And we have a third step that would be the formation of rock. And this would trap a large amount of the CO2 that is injected. So after that time, we have a safe enclosure of the CO2 in rock. And this process will occur on different time scales, depending on the composition of the different types of sandstones. We do these experiments in order to understand the process. And this process, if we understand it, can be applied worldwide.
Wenn ich dieses Bild hier nochmal etwas hervorhebe, wenn ich diesen Bereich vergleiche, ich sehe, dass ich hier eine deutliche Lösung habe.
The release of CO2 in the next 10 or 15 years will be incredibly high. And if we want to escape this problem, we have to have a technique that can be used easily. CO2 storage could be one part of the solution.